Hey everyone, this is the first part of the video going over the test 4 review. We're going to go over the topics in this outline and look at the equation sheet here to help us along the way. So test 4 deals with light and geometric optics. The first thing that we learned about in the chapter on light was electromagnetic waves. We learned that there are different types of EM waves. They're arranged in the electromagnetic spectrum according to their frequency or wavelength. We know that they all travel at the speed of light in a vacuum. I should have specified that here. And so the speed of light in a vacuum is a constant, so that's c right here. C is equal to 3 times 10 to the 8. That's at the top of your equation sheet. And the speed of the light is equal to the wavelength of the light times the frequency of the light. Since the speed of light in a vacuum is constant here, that means that if you solve for one of the other two variables, such as the wavelength of light, sub-zero here just means in vacuum. This is because the wavelength of light does change if it travels into a different medium. But if you solve for wavelength here, you can see that since c is a constant, that lambda and f are inversely proportional. So an electromagnetic wave with a high frequency has a low wavelength. So they're all arranged in the spectrum. You don't have to memorize the order. You should be able to recognize all the different types. So radio, microwaves, infrared, ultraviolet. There's also X-rays and gamma rays as well. And of course, there's also visible light that falls in between here. So if I asked you which one travels faster, your radio waves or your microwaves, then you would say, well, they all travel at the speed of light in a vacuum, so they all have the same speed. So you should be able to recognize the different types of EM waves. Then we learned that light slows down in a medium and that the index of refraction of that medium tells us how much light slows down. So that's this next equation right here. N equals c over v. So c is the speed of light in a vacuum, but v is the speed of light in that medium. N is always greater or equal to 1. This is because v is always smaller or equal to c, right? So if v here is a smaller number than c, then that's going to make our n value bigger than 1. So what you should understand conceptually about this is that the higher the index of refraction of the medium, that means the slower that the light travels. But as far as finding that speed, it's just a plug and chug. If you're given the index and then you have the constant c, then you can find the speed of light in that medium. The next thing is dispersion. So we saw that light separates into the different colors of the rainbow. And we didn't go into a whole bunch of details, but basically your different colors of light. So when you have your white light that hits your prism, your different colors of light travel at different speeds, and that makes them bend different amounts. So it's as though each different frequency of light has a different index of refraction in that medium, and that's why it bends different amounts. That's a way that you can think about it. But all we are concerned about is the main effect here, that the reason that the light is splitting up into all these different colors is because the different frequencies travel at different speeds. So we actually didn't cover this equation here, so we don't even have to worry about this equation. Then the next topic is going to be looking at light as rays and then looking at how those rays behave when they go from one medium to another. So let's look at the first thing here, which is the law of reflection. When you have a ray of light is incident on a surface, First of all, you always want to define the angle of that ray with respect to the normal. So you draw that normal line here that's perpendicular to the surface. And your angle, let's call it the incident angle, is always the ray that is going to hit that boundary. So that's going to be your incident angle, your angle of incidence. The law of reflection says it equals the angle of reflection. So that means it's going to be reflected at the same exact angle, which we can call angle R. So you should be able to visualize that and do that as well if we have a ray reflected off two surfaces. So for example, if you have two surfaces, let's say that they're at a 90-degree angle, then if you have a ray going this way, then it's going to be reflected the same angle. So if you have that normal to the surface right here, that those two angles are going to be the same angle of incidence here, angle of reflection here. And then this ray is now hitting the second surface, and then it will also be reflected at the same angle of incidence. So now there's a normal here, and then this angle here is going to be the same as this angle here. This is the angle of incidence equals the angle of reflection. So you should be able to use geometry to figure out the angles.